So we go back to our same chart and what we were discussing last class, that matter can be divided under two heads. One is pure substances, and impure substances. Children, this chapter will be very much, focusing more on the impure substances. Pure has two forms, elements and compounds. Okay, and we discussed a lot about these. Elements and compounds are called pure substances because they are made up of one kind of particle. Elements can be made up of only atoms or molecules, whereas compounds will always be made up of molecules. And to form compounds, elements, two or more, chemically combined. There's always a chemical combination, right? And therefore you create a new particle. Either elements can be in atomic form, so I'm writing it further. Elements can be in atomic form. Elements can also be in molecular form, whereas compounds can only be in molecular form. An example would be atomic oxygen, molecular oxygen, and carbon dioxide. This is all that we had learned in our last class, right? Now, these elements, which are the pure substances, when we talk at a basic level, we'll not talk at compound level also, because compounds are also made from elements. So we'll talk at the level of elements. Roughly around 114 elements, and you need not be so ballpark correct on that figure. These elements there are artificial elements as well as natural elements also. Elements are further classified when you see it from physical form. Then elements are classified as metals, non-metals, and you have someone in between which is known as a metalloid, right? Grade 10 we have a chapter called metals and non-metals, where you will be studying this side very, very elaboratively, right? Okay, when you talk about compounds and you study compounds chemically, okay, chemically every compound is classified into either of the three groups. We study them as either acids, either bases, or as salts. Now, this is a chapter in grade 10. This is also a chapter in grade 10, right? Understood? In grade 9, we will be just having our basic clarity on this. However, at grade 9, we will be focusing on this one also in the next chapter, atoms and molecules, and then in the subsequent chapter. So, we will have a lot of focus in grade 9. These will be grade 9 topics. Okay, further, what do we get to know from here? If you look at the elements, the elements are in their physical form, whether they are metals or non-metals. All the elements will be in the form of solids or gases, and the liquid is very stylish. If you have liquid, you have only one element each in the category of metal and non-metal, one element each, which is a liquid. Apart from that, everyone is either a metal or a gas, right? If you are in the metal category, then we have iodine, non-metal, and not iodine, mercury. Okay, iodine is we have mercury and we have bromine. Remember these two. Bromine is a non-metal, which is usually a gas, and mercury is a metal. Did you understand this? We have only two liquids. The liquids are mercury and bromine. Bromine will be represented by the symbol Br. Mercury will be represented by the symbol Ag. So these are the only two elements which are liquid. And each of them one has been attributed to metal and one has been attributed to non-metal. The question kabhi-kabhi pooch leta hai that which is the only liquid non-metal. The only liquid non-metal is bromine, and the only liquid metal is mercury. Means mercury is a metal which in room temperature is in liquid state, and bromine is a gas which in room temperature is in liquid state. Okay, itna yaad rahega, right? If that be the case, today we will be focusing more on, our discussion will start into impure substances, and later on we'll come back again to elements. Yahan tak any doubt anyone has? Any doubt? Even from last class, if you have a doubt, don't hesitate. Okay, shall we go ahead? Okay, so now we go to impure substances. In impure substances, the broad categorization will be known as mixtures. Mixtures. So we'll first talk at a higher level. What is a mixture? A mixture is exactly how you eat either a jhalmuri or a bhel puri. It's just like that. Everyone has a different taste of chilies. Everyone has a different demand of chilies, salt level, mustard oil level, coconut sheddings, or the namkeens that you want, groundnuts fried. We all have different likings. So there cannot be a bhel puri which is a universal bhel puri which we can serve to everyone. She may like it different way, you may like it different way. So what is a mixture? A mixture is a mix-up of either can be elements and compounds, can be two or more compounds, two or more elements and compounds in which they are not chemically combined together. Understood? In a mixture, we will have a mixture will comprise of elements or compounds or both, or element, compound and another mixture. We already have one mixture. In that we are mixing another element and compound, right? Or both, not chemically combined. That's why I said it is just like a bhel puri, not chemically combined. And further we will say in an undefined proportion. In an undefined proportion. Why do you say in an undefined proportion? Just look at here. If I talk about a compound called water, if I call a compound like water, and I am sourcing water, whether it be from London or it be from Banalguda out here, then a sample of water will, one molecule of water will always have 2 atoms of hydrogen and 1 atom of oxygen chemically combined. You cannot have water as H3O or HO2. That's not possible. Means here the recipe has been defined. It's something like the burger that you have in McDonald's. If I offer you a burger from McDonald's and I ask you, tell me from which outlet of McDonald's did I buy it? Will you be able to say no? Because that is a recipe based food. We do not do anything. But if you cook food at house like biryani and something, you can always say this is from that restaurant. They have this taste. That's like a mixture. That's the what you call an analogous explanation to mixture and compound. In compounds, we will have elements which are chemically combined in a fixed proportion. Here it is an undefined proportion. It's not fixed. I may mix anything to my choice. Right? And since it is not chemically combined, what we discussed the other day, the same thing, it is not chemically combined. So we will have parental properties of constituents are retained. These properties won't be lost. So what am I trying to say? The same example. Hydrogen and oxygen chemically combined together produces water. Hydrogen is highly explosive and oxygen supports combustion. But when you make water, it doesn't support combustion. It is something which is used as a fire extinguisher. A same example out here. If you take iron and if you take sulfur and if you just mix, then you are having a iron and sulfur powder mixture. Bring a magnet, all the iron can be separated. But if you have this mixture and you heat it, in which you're making a chemical change, you develop a new substance called ferrous sulfide. And ferrous sulfide will not attract magnet. But that is a compound. Now here, it's just a mixture. Have you understood? Broad level, anyone has any query? What is a mixture? A mixture is a mix-up. Or a mixture is a substance that is composed of 2 or more elements or 2 or more compounds or elements and compounds mixed together in an undefined proportion, not chemically combined. So isme 2 words are your keywords, not chemically combined, and the other keyword is undefined proportion. That is, there is no fixed proportion. right? Chemically combined hota to naya property aa jayega. This is not chemically combined. And second is, if the proportion had been defined and chemically combined, then it becomes a compound. Clear so far? Right. Can we go further now? Okay, further. When we talk about mixtures now, mixtures are broadly classified again under two heads, which is known as homogeneous and heterogeneous. One more thing that was that I missed out, maybe mixtures can be separated. In mixtures, constituents can be separated. We'll write that. In a mixture, you can separate the constituents by physical methods. Even if I give you one pack of bhel puri and I ask you, can you just separate everything? You can separate. Only thing is that it will be more tedious and time consuming, but doesn't mean that you can't separate it out. You can 100% separate it out. Okay. Mixtures can be homogeneous and heterogeneous. In a homogeneous mixture may have constituents, and these constituents can be constituent 1, constituent 2, constituent 3, right? Constituent 1, constituent 2, constituent 3. All these will be uniformly mixed, and there will be one single composition or one single phase. One single composition, you will see, or one single phase. No distinguishable layers. You can't make it out. All of you have had tang, or glucose. Tang, suppose you have orange tang. If you take 2 teaspoons of tang and you mix it in water, after that you cannot say where is tang and where is water. It is a uniform composition. Single phase. You won't see 2 different layers. That's why we call it a homogeneous mixture. A homogeneous mixture का एक बढ़िया example है solution, and another is alloys. We will talk about both solutions and alloys. So let's first understand what is a homogeneous mixture. Homogeneous mixture is a mixture in which two or more constituents are actually mixed together in such a way that there is no distinguishable layer, and you see it in one phase. आपको एक ही phase में दिखेगा. Either वो solid में ही है, air में ही है. Like air is a homogeneous mixture. Can you see air? No. But in that air, can you tell how much is oxygen and how much is nitrogen? You can't say that. So it's a homogeneous mixture. In one composition you will see, or in one phase, either in solid phase or in liquid phase, we will be seeing it, right? Let's talk a little bit about alloys. Alloys का बड़ा छोटा सा description है. But when you talk about alloys in mechanical engineering, the alloy itself is one subject. So many things. And alloys is the best thing that all of you must have studied about Bronze Age civilization, right? Bronze Age. जब bronze पैदा हुआ, आप history में नहीं पढ़े हैं? When man started to know about metals. Yeah, so there was an age which was known as the Bronze Age civilization. So people used to earlier hunt with what? Wood and sticks and all. तलवार कैसे बनना शुरू हुआ? And how people started developing various technologies by which they could make armories and weapons. That, you know something called quenching. लोहे को गर्म करते हैं, गर्म करते it will be then put into cold water or cold oil, and it will make a noise, buzz करके आवाज करेगा. Quenching करने से hardness बढ़ता है. So those kings and all, do you visit museums and all? Have you visited museum? In fact, if you visit the Victoria Memorial has that in Kolkata. Sirajuddaulla's sword is kept there. You can't even lift it also. Maharana Pratap's sword used to be very heavy. You can't lift. They used to fight with those. Then came, if you know the story of, have you heard the name called Constantinople, which is present day Turkey? Okay. So Constantinople walls never fall. And when the Ottomans started attacking, that was the first time the cannons were made. Cannon. And cannons are supposed to continuously fire. So imagine their metallurgy. वो खुद पिघल नहीं सकता है. After firing also, so the cannons were the most important thing which made the walls of Constantinople fall. And Mehmed from the Ottomans, he attacked and the Romans were overthrown. And then it became Turkey, which is present day Turkey, which is say, okay. So cannons, all these were knowledge about man of metallurgy. And all these things work on alloys. What is an alloy? An alloy is a homogeneous mixture of two solids. Ultimately, you will see everything in a solid shape. For example, brass and bronze. Brass and bronze. In Hindi, bronze is called kansa. Kansa padat bolte hain na, swarn padat, gold medal. Rajat padat means silver medal, and kans padat means bronze. Bronze is copper and tin, whereas brass is known as pital. This is copper and zinc. Brass is very costly, very, very costly. In every industry and plants, there's a lot of pilferage that happens with brass. Chori karte hain log. All the fire hose hydrants that you see, have you seen the fire hose hydrants? They are coupler which is kept right where, which is coupled with the tap. That coupler is made up of brass. Brass is very costly, and people actually pilfer this. So brass is an alloy which is made up of copper and zinc. Similarly, when you do soldering, the solder wire is an alloy. This is an alloy of tin and lead. But the interesting thing is, while solutions can be separated physically, alloys cannot be separated physically. Steel, जिस थाली में आप खाते हो, steel is an alloy. Steel is an alloy. Can you tell me steel is an alloy of what? Iron and carbon. Iron and carbon. Steels are of various grade. That particular grill on our balcony, we call it mild steel, MS. Then there is called cast steel. Then the steel that which you eat at home, that is stainless steel. So that will have little bit of vanadium. Then we want more hardness in steel. Suppose you want to make it, TMT Salia bar, those ads come. You want very much hardness, then you can add vanadium to steel. So all these are alloys, different grade. So mixtures can be homogeneous. An example of homogeneous mixture is solution and alloy. We first discussed about alloys. What is an alloy? An alloy is a mixture of two or more metals in solid form. The distinguishable feature of alloys from solution is that while solutions can be physically separated, he has taken water and he has put sugar into it, and now he wants to separate. Heat up, the water will evaporate, चीनी नीचे रह जाएगा. But you can't do that with here. इनको नोट कर लीजिए, ये आपको पूछता है. लेकिन brass and bronze and also solder, alloys. Alloys example, steel भी ले लीजिए. Steel is an alloy of iron and carbon. Steel is an alloy of iron and carbon. Okay. Then we'll go back to solutions. Our next discussion will be solution. So remember the tree where we have gone inside. From matter, impure substances, impure we have entered into mixture. In mixture we have entered into homogeneous mixture. In homogeneous mixture it had two children, solutions and alloys. Alloys we have studied, and now we are going back to solutions. Acha, what is the distinguishable feature of alloys with solution? While alloys cannot be physically separated, solutions can be separated, and an alloy solution is usually always in liquid state. Alloys will always be in solid state. An alloy is a mixture of two or more metals in their molten state, which has then been solidified. And after it has formed alloy, it will be a uniform texture. Okay, you must have had, like say, some chocolates have you had where you see the milk layer also. It is a solid chocolate, but you can see the milk contour also and the cocoa contour also, the chocolate contour also. Alloys are not like that. Copper in molten state, zinc in molten state. It will, once an alloy has been made, you won't see a copper strand or a zinc strand. Like you see ice creams, you see strands, right? You see vanilla and you see chocolate. You won't see strand. You will see a single strand. इसीलिए तो वो homogeneous है. So put your brains, huh? You cannot see two strands of metal. If you see two strands of metal, then it defeats the definition of homogeneous. Two distinguishable layers won't be there. It will be one layer only. And the one layer is a different color, which is neither the color of copper, not the color of zinc. It will give a new color and it will be consistent throughout. And that is known as an alloy. Okay? So alloys are always in solid. Examples of alloys can be the steel, you can have brass, bronze, solder. याद रहेगा ना, brass और bronze में लोग गड़बड़ कर देते हैं. हमेशा याद रखिए, brass is more costly. Brass has got copper and zinc. In Hindi we call it pital. And this is what all idols of god and goddess are made out of this. And if you use, this will have some layer of oxide on it. So when people take out old utensils for, puja or something, they will take something called lemon and start cleaning it. Or there is another detergent also called pitambari. तो pitambari से इसको घिसने से एकदम बढ़िया कलर आ जाता है. ठीक है, आगे चले. So we'll go back to again solution. तो थोड़ा सा याद दिला देते हैं आपको कहाँ हैं हम लोग. So we are in matter, and in matter we are in impure. Impure मतलब we are in mixture. In mixture we are studying homogeneous. Homogeneous we have got alloys and we have got solutions. Right now this is done and we are going to study solutions once again. Okay? We'll come back to solution. Solution means it will be in liquid form. It will be in liquid form. Majority. Okay. Solution which has only two components, which is known as solute and solvent. In higher grades we call them as binary solution. What does the word binary mean? Two. Binary means two. Okay. Binary means two. You have two components, that's why we call it a binary solution. समझ में आ रहा है? Okay, now we will talk about solute and solvent. Solvent. यहाँ भी बहुत confusion रहता है. If somebody asks you that I have got a glass of water and sugar granules are into it, after that the sugar granules has to disappear. Then only you will have one composition and then only you can study it under solution. So question comes is, what is solute and what is solvent? है ना? Solute क्या है, solvent क्या है? Try करेंगे थोड़ा सा answer. Any guess which is solute? Solute is the sugar, solvent is the water. Okay. Is it necessary that sugar will be the solute? No. So on what basis did you say this? What basis did you give this answer? You're correct. But there is a different, I just want to say on what basis. Everyone participate. I mean, then only it makes good. Ahan, there is no point keeping quiet. You know it, please participate. How do you understand that? Why did you say sugar is a solute? And you have to have some empathy for me. I can't keep speaking 1 hour.
Solute is the solid dissolving in the liquid.
Solute is the solid dissolving in the liquid. That means, okay, let me tell you one thing. I am having 1 glass of milk. I don't like to have milk in this manner. My wife has sprinkled 3 drops of vanilla essence into it. What is solute and what is solvent now? Vanilla is the solute. So can you answer what is making you give this answer?
The quantity is small.
Solute is the substance that is dissolved. Okay. One way we will understand it and try to keep it in your mind throughout. Okay. 2 ways you can actually answer this question. Number one is on the basis of concentration. On the basis of concentration. In a glass of water, which is more concentrated, water is more concentrated. The one which comes in lesser concentration is usually the solute. So this is easy for me to answer something like sugar in water, or it is easy for me to answer what is salt in water. Now let's do something called some mischievous act. there is a lump of sugar out here, a lump of sugar, huge factory, and we have gone with some 5 ml syringe of water, and we are doing pinch, we are putting 5 ml of water into it. Now which is solute and which is solvent? Water is the solute, sugar is the solvent here. So you can answer this by concentration. Another way to answer this is the final state. The final state means you take solute beta, you mix it in, you don't know which is solute or which is solvent. So I will say component 1 plus component 2, right? Component 1 may be solid or liquid. Component 2 may be also solid or liquid. Then a final state, it will be either a liquid or a solid, whatever it is. Whichever component initially was in the same state as the final state is the solvent. I'll come to that. So let's say we have sugar, we have water, and finally I have here what is known as a solution, right? So what is the final state? Liquid. Water was liquid, sugar was solid. Which component had the same state as that of the final state? Water. Water is the solvent, right? In one bucket of blood, if you mix little bit of water, then both are in liquid form. That then answer it by concentration. Whose concentration was more? Blood's concentration was more. So blood is the solvent. Solvent is one in which solute spreads across. Best answer. This is the third one. So one is with this, one is you can answer by this or solute dissolves or spreads into solvent. अब देखो आप सब आंसर कर पाओगे. Half liter blood mixed with half liter water.
Blood is
Both can be solute and solvent. Both can be solvent because the concentration level is same. Are you getting it? The concentration level is same. Either one can take over the role of the other because initially both were in liquid state. Final state is also liquid. So whenever you see a binary solution will be always liquid. So the solute is supposed to be always solid. And in grade 9, we will be dealing more with solids only, right? So can you now tell me about homogeneous solution? Some examples. Homogeneous solution can be salt solution. Homogeneous solution can be, yeah, potassium permanganate add in water, which is a chapter which we did not study, right? Then you can also have lime, copper sulfate. Copper sulfate is not a, copper sulfate is a compound. Here you have to make it a mixture and make a solution. What you are saying is an aqueous solution of copper sulfate. It is a compound which has been mixed in water, right? It qualifies the definition of solution because it depends how much of, see, she is trying to give the example of copper sulfate. Copper sulfate is a compound, but it is mixed with what? Water. Concentration may differ. So it is a mixture. But if it is only copper sulfate which is mixed, then it will be copper sulfate aqueous solution will be treated as a compound. Here we are dealing about 2 or more substances. Okay. So,
How can we find the by the final state?
solution by the finals, not solution. How can you distinguish which is solute or solvent? Say component 1 and component 2 are mixing to form a solution. Solution to liquid hi hai. Now look in component 1 and 2, who was of the same state as that of the final? That fellow will always be the solvent. Milk and sugar. So what do you get? Sweet milk. Sweet milk is liquid. Initially sugar was solid, milk was liquid. So milk is the solvent. In solvent, the solute always spreads and mixes across. ठीक है, थोड़ा और solution के बारे में देखते हैं जो पिछले chapter में था, and I think you should know about it. Okay, solution. So in a solution, I will have a solvent, and in that solvent you will be adding what? Solute. And in this process we say solute dissolves into solvent. Sir, who gave you the right to say that the solute dissolved into the solvent? Because I'm studying solution, the solute has to dissolve. I'm giving you one composition, right? Now question is, how much of solute? How much of solute will dissolve into? For that, let's go again and see the kinetic theory of matter, which was interesting thing in last chapter. So you have got solvent particles. So say water particles, and these are my water particles. They will always have what? Intermolecular space between them, right? And intermolecular space will create some gaps. In these gaps, what is happening? The sugar particles, what did we take? Sugar, right? Okay, sugar. The sugar particles are coming and sitting in these gaps. Agreed? So lots of gap. It's an empty bus. It's your first pickup at the bus stop. Go and sit in any seat that you want. Slowly children are getting up, and by the last seat, what happens? Almost all the seats are filled up. And we say that the bus is full now. Can it take one more child? Can it take one more child? It's a question now. We can't say yes or no, because there will be some children who will be sitting little bit royally. Like say I used to sit, or our friend Rishika sits, me and my bag. There are some children who are sitting like this. You actually can't say that whether another child can come in or not. You have to create space. So in order to create space, what you have to do, you have to increase the space. If you want to increase the space, you have to reduce their attraction. You have to reduce their attraction. So the best way to increase their space is what? You make them vibrate. Story ko ekdam stories jaise jaiye. I have got, let's say this is that last bacha from the bus stop. He has boarded the bus. We will make this bacha sit out here. So what? You have to create some space. So in order to create some space, what do you have to do? You have to make these couch potatoes which are sitting, you have to make them vibrate. So vibration means what you have to do? You have to supply some bit of energy. And this energy will be in the form of heat. As soon as you supply heat, right? What happens? The kinetic energy of these molecules will go up. Understood? If the kinetic energy of these molecules go up, this is related to the temperature also. The temperature will go up. Or the heat can also be used to only weaken the intermolecular force of attraction. This was something very interesting in last chapter. Latent heat, concept of latent heat. So it can either weaken the intermolecular force or it can increase the kinetic energy. Kinetic energy increase means the temperature. Temperature is a measure of kinetic energy. More is kinetic energy, more will be the temperature. The temperature starts shooting up. As soon as the temperature starts shooting up, their vibrations will start. And once they vibrate, spaces will be created between them. And once you create space, this bacha can happily go and sit. Maybe two more bachas. After that, we are no more able to have any further addition. What will happen? If you add, yeah, very good. If you add a little bit more of sugar now, that sugar will come and it will be visible up. It will not get dissolved. At that moment, there will be some temperature of your room and some pressure of your room. At this temperature and pressure, when you are unable to dissolve any further solute, you say that you have created something called a saturated solution. So saturated solution definition does not become complete unless and until you specify what is the temperature and pressure. The bus conductor and the driver or the IMMA, bus conductor and the IMMA, they were so lenient that they did not scold these kids further. Get inside. So at their temperament, we said that the bus is full. Tomorrow a new staff comes up. Hey, get inside. Once the moment he says like that, you create some more space. So once you increase the temperature or you increase the pressure, you will have more solubility seen. Another way can be, why don't we go for a bigger bus? Increase more solvent. Sugar is not getting dissolved. और पानी डाल दो और सारे seats खुल गए. Now the child can happily sit. So whenever you define saturation of a solution, you should say what is the volume should be fixed. Therefore, in saturation they will define that the maximum amount of solute that can be dissolved in 100 ml of a solvent at a constant temperature and pressure is defined as the saturation point. Beyond this, I won't be able to dissolve any further solute. At that moment, we call it as a saturated solution. ओके, सैचुरेटेड सॉल्यूशन को फिर से थोड़ा सा टेम्परेचर वगैरह देके यू स्टिल डिसॉल्व समथिंग मोर, दैट टाइम वी कॉल इट अ सुपर सैचुरेटेड सॉल्यूशन. इससे ऊपर और नहीं होगा. लाइक व्हेन आई गो फॉर डिनर इनविटेशन, फर्स्ट ऑफ ऑल आई विल ईट वन राउंड. क्या जयदीप कुछ खाए ही नहीं हो, सो दैट वाज सैचुरेटेड, आई एम डन. नहीं नहीं नहीं, ऐसा थोड़ी होता है. वन राउंड मोर, दैट वन राउंड मोर मीन्स नाउ द फूड हैज कम एट दिस लेवल. If I don't get water, it may burp out. That is called super saturated. So always eat up to saturation or a little bit less than that, because people will force you. यहाँ तक खाने से तो ये बाहर आ जाएगा. Is the concept understood of solute, solvent, solution? What is saturation of a solution? And the next comes solubility of a solute. Solubility can be enhanced by what? Increasing temperature, increasing pressure, increasing dilution. If you dilute it, more can be soluble. Are you? How many of you have made caramel? I give this example many times. So once you make caramel, you cannot take too much dilute of it. You have to take a very thick. You add a lot of sugar into the frying pan and add some little bit of water. Zyada mat do, because end of the day the water has to evaporate out. Then only it will become a very very thick caramel, sticky thing. ठीक है ना? समझ में आ गया? चलिए और थोड़ा solutions को देखते हैं. Now, further, in solutions, we will have particles, and the particle size will be less than 1 nanometer. Nano means 10 to the power minus 9. 10 to the power plus 9 is known as giga. 10 to the power minus 9. 1 nanometer. इतना छोटा होता है particle. Particle तो है, नेकेड आई से विजिबल नहीं है. सॉल्यूशन पार्टिकल साइज इज वेरी लेस. इसके लिए क्या होगा? नॉट विजिबल अंडर माइक्रोस्कोप. हाँ, दे आर नॉट विजिबल. सॉल्यूशन में आपको चीनी नहीं दिखेगा. यू मिक्स शुगर, यू वोंट सी द पार्टिकल डिफरेंटली. नॉट विजिबल. ओके. देन नंबर 2, कैन नॉट बी फिल्टर्ड using filter paper. Filter paper, children, what is the concept? A filter paper is porous. It has got holes in it. If the hole size is this much and the particle size is smaller than that, वो कैरम के कॉइन के तरह पक करके चला जाएगा. So you can't catch it, right? Okay. They are very small. They cannot be visible under the microscope. Cannot be filtered using filter paper. Okay. Then they are very stable. What do you mean by stable? Stable means if you take 1 glass of Tang, you have mixed 1 spoon or 2 spoons of Tang powder in 1 glass of water, you make Tang solution, and after that you have stirred it well. If you allow it to rest, after that you won't see that the particles have again settled below. Stability is very high. ORS. जब आपका dehydration होता है, आप क्या पीते हो? ORS, oral rehydration salts or oral rehydration solutions. जैसे आप you take ORS and you start mixing it, the good property of ORS and glucose will be that immediately it will dissolve. Immediately it will dissolve. And after dissolving, it is very stable. आप उस बोतल को कैसे भी हिला के फिर रख दो, उसमें आप particles को अलग नहीं कर सकते हैं. But there is one technique I told you. Take a ORS pack, empty it in a bottle, and let it mix well. Just take the bottle and put it in refrigerator. Normal compartment, not the freezer. After 15-20 minutes, the entire ORS salt will be seen at the bottom. Why? Because once you put it in the fridge, the Ayamma and the bus driver and bus conductor left the bus. And those students again kept their bags. And these poor little primary children, they were forced to get up. And they will show up. Understood? You can do that. Whenever you are having ORS or something in a glass, you just mix ORS and then you put it into the refrigerator. After some time, you will see. इसलिए बोलते हैं, don't be, sometimes unknowingly we do a lot of foolish acts. We think that the person has dehydrated, इसको ORS दो, and now it is summers, so somebody will say, get fridge water. Fridge water में ORS mix नहीं करते हैं. The ORS will not mix properly. Mix it in normal water. Mixing ORS in fridge water is a foolishness. Since the temperature of the water is less, the salt will not dissolve properly. So what our patient will be drinking is only water, and pure component will be right down below. Okay. Ready-made ORS packet which you Tetra pack, that is already mixed. वो तो मिक्स करके रहता है उस वो that is not that good, that is only for flavor purpose which you have this, but even if you keep it in refrigerator there also you'll see settling below, but you can't see it because it's a Tetra pack. Best is buy the powder, mix it in a bottle of water and just put it in refrigerator, it will just come up. इतना हो गया. Okay.
Sir,
Yes sir.
in hot water, will the solute dissolve faster?
Yeah, hot water the solute will dissolve faster. Hot water is like a bus where the IMA and the bus conductor are very strict. They keep on blasting the senior kids. So senior kids are already separated and all primary children will come in. Hot water dissolves everything faster. Have you used when you will be maybe traveling in Shatabdi or you are going to a hotel and all, you get those dairy whiteness every day, sachet to make your tea. Nowadays somebody gives you milk also in liquid form. I'm saying everyday sachet, है ना? उसको क्या बोलते हैं? Skimmed milk powder. Amul is milk powder. Everyday is not milk, is dairy whitener. दोनों में फर्क है. अमूल को खाने से आपको मजा आएगा. You'll get that taste, that milk taste will be there. That thing, if you actually pour on cold water, it will coagulate. उसको गर्म पानी में छोड़ते हैं. To answer his question, if the cup of water is hot or lukewarm, at that time if you empty the contents of that sachet, the mixing will be much more better. If you actually empty it in cold water, it will just form a lump. It will mix, but with difficulty. थोड़ा सा difficulty हो. Right? Shall we go? Solutions, okay. Now here we have to understand one more interesting thing, which that parameter I'll not teach now. That parameter I'll teach when I teach colloids to you, okay. So what are solutions? Solutions are those in which you will see a complete one phase, okay. Those I have not written. I hope you have copied in the previous slide. In solution, mixtures are mixed consistently and the composition by mass is uniform. Composition by mass is uniform means you take a glass of tang, you sip 1 spoon from here, or you sip 1 spoon from the bottom if possible, or you sip 1 spoon from the side, you won't find a difference in taste. So the composition by mass in a solution of its constituents is very, very uniform. It will be always seen in one phase and there won't be any distinguishable layers which demarcates the two components. Typically, let's say oil and water. Oil and water don't mix. So that's not a solution. That's a heterogeneous mixture. Then the particle sizes of solutions are very small. They're in the size of 1 nanometer, which does not make them visible even under normal microscope. And they cannot be filtered using normal filter paper. So you can't separate it out. And a solution is very stable. Irrespective of how you have handled it, you take tang from here to school and you twist and turn your water bottle and you go and keep it back. You can't expect the tang to settle down below. It will be mixed uniformly throughout. समझ में आया इतना? Right? So this was about solutions. That is all about the homogeneous part. So where were we? Matter, impure, mixture, hetero, homo. In hetero we studied alloys. In homo we studied alloys and we studied solutions. In solutions we understood solute, we understood solvent, we did an extra topic on solubility. We also understood what happens to a saturated solution. Then how can you increase solubility by either diluting it or by increasing temperature or by increasing pressure also you can increase solubility. Then further we saw that what about the particles? The particle sizes are very small in the order of 1 nanometer, cannot be filtered using filter paper, is usually undistinguishable, the composition by mass is very uniform throughout the solution, as a result of which it is also very stable. Our focus now shifts into heterogeneous. Heterogeneous mixtures. Heterogeneous mixtures are those mixtures in which the two constituents do not mix thoroughly into one another. As a result, one component will spread over another either as particles or as bubbles means there is a distinguishable difference. In heterogeneous, two or three components will never mix with each other thoroughly. As a result, one particle, if it is suppose a binary heterogeneous mixture, one component will be spread over another either in the form of bubbles or on the form of particles. समझ में आ रहा है ना? So shall we talk about heterogeneous mixture? So in heterogeneous mixtures, for example, let's give you example of say sand in water. Sand in water, the moment you drop sand in water, you'll see all the sand below. It's a mixture, it's heterogeneous, you can see both separated and quite nicely separated. So one will be spread over the other. The sand is seen in a particle form. Heterogeneous mixture in our studies are of two types, suspensions, and the other one is colloids. Let's first understand about suspension. Suspensions are homogeneous mixture in which solute particles are clearly seen, clearly distinguishable in the solvent or in the solution. नहीं, oil तो liquid हो गया. The best is you use face wash, right? Face wash which has got scrub particles in it. Can you see the scrub particles? Chia seeds dipped in water. So you see them very nicely. It can be seen. But why are you going to so high level examples? All of you had it when you were a kid and you used to have fever. What is the medicine that used to be administered with? What is the medicine you take? Come on, this is life. You should be having your what do you call basic life science knowledge. If you have fever, what medicine do you take? Dolo. But when you are younger, what are you fed? Crocin. Crocin. When you go next time to MedPlus and somebody is buying crocin for a baby, they will say pediatric crocin dijiye. That crocin will come as a suspension. Crocin is not a syrup. Crocin suspension. And the first thing that will be written on it is shake well before use. The medicine component is very small, otherwise the child will not have it. So there will be some pineapple flavor or some other flavor in which the medicine will be introduced. So you are supposed to shake it properly and then pour it over a spoon and then feed the child. Crocin suspension. Cough syrups. Cough syrups are also cough syrups and cough suspensions. You're supposed to shake it properly. For example, milk of magnesia. Digene. If you see digene, have you seen digene? Pink color. Pink color one is known as gelycine or digene, which is used for digestion. Okay. So digene is your antacid. And come on, at grade 9, at your level, I used to know much more medicines than you. Antacids. You will be going for school camps and all. You should know the antacid. Whenever you have it, you are supposed to first shake the bottle because you're not having it every day. So the entire suspension has gone below. Suspension means what? Suspended. Something is suspended. So here the solute particles will remain suspended into the solution or the solvent. Best examples are, have you had what you call when you go to Mahabaleshwar and all, you buy these what do you call strawberry pulp. So when you have the pulp and the crush, so when you drink the crush, don't you feel the pieces and the chunks coming, right? But they're very soft, just like water itself. That's a suspension. That's a suspension. So suspensions are heterogeneous mixtures in which the solute particles remain suspended. The two layers will be clearly visible. If not two layers, you will at least be able to distinguish the constituents in the form of one as a solvent and one as particles. Chia seeds, water. Nowadays, everyone has it. So when the chia seeds get dissolved, you will see water and chia seeds. You can see it. It will not. Crocin suspension. Milk of magnesia is a suspension. Cough syrups are suspension. In suspensions, there is no hanky-panky business. If you talk about their particle size is greater than 100 nanometer. That was 1 nanometer. This is greater than 100 nanometer. So this makes it very easy. So what will happen? Easily separable by filter paper. And the whole solution or the mixture will be very, very unstable. What do you mean by unstable? After feeding the child crocin suspension, if you keep the bottle stacked back, again the medicine will all go and settle below. What will be on top is only the additive component of it. Therefore, if you do, even Amul Chach, the small green packet that we have, Amul buttermilk, 10 rupees. Yeah, they will say first shake it, otherwise you will be sipping only the water portion of it. And it won't shake properly if you buy the 1 liter Tetra Pak. And if you shake it properly before, suppose you're trying to shake it before opening or unscrewing the cap, still it will not shake properly. You're supposed to take off the seal and then maybe gulp 1 or 2 ml of it, create some space, and then shake it. Then you will see a uniform white color. So buttermilk is also a clear example of suspension. Even the lassis that we get in Tetra Pak, and then start drinking it. Otherwise, you will be finding it very, very dilute. Okay? Very naked eye में visible हो गया, easily separable by filter paper. Yeah, this is visible in naked eye. 1 minute, huh? Constituents are visible by naked eye. Microscope की जरूरत ही नहीं है बेटा. Unstable means, did you understand? The solution is, the suspension is an unstable mixture. Means if you shake it also, if you shake it will mix. Not all. For example, your face wash, which has got scrub particles in it, if you shake it also, it will not mix. But say for example, I've got crocin suspension and I shake it, it will mix properly. But if you stack it in a rack, unstable. Again, the stability is not there. Understood? Now the dangerous fellows are these ones. Just a little bit of introduction. We will study this more in detail in next class. Colloids. Colloids are very dicey. They are from 1 to 100 nanometer. 1 to 100. Being 1 to 100, they will not be caught by the naked eye. Neither sometimes by microscope also. No. They will pass the filter paper also. But there is one test which they will fail, which will actually make you realize that they are not solutions. Examples of this: blood, milk, starch water. Okay.
Alum is a colloid, right?
Alum. So no, vinegar is an acid. The best example is blood. All right. Blood, if you actually pour it through the filter paper, it will go through. Milk will go through. तो आपको क्या लगेगा? नहीं, centrifuge तो अलग चीज है. Centrifuge is a way of separating. Separating तो I can do for sugar and salt also. But my question is, this one comes in disguise. He says I'm a solution. But there will be one test which it will fail. One test it will fail. ठीक है ना? About that is scattering of light, which we will discuss in our Tyndall effect. Okay, this we'll discuss in next class. So today you have understood about solutions, you have understood about suspensions. Colloids are in between. Colloid will show every property of solution, but are not solutions. They will fail in one test, which solutions will pass, and suspensions you don't need to test it because suspension तो ऐसे ही पकड़ा गया. ठीक है ना? तो इसको